All right. Thank you very much for coming to this session about Monolith. Probably you're thinking about why Monolith nowadays that everyone is talking about microservices. Now you're talking about Monolith. I know that most of the things that I'm going to say are common sense, but I think that it's always nice, to check the slides and say, yeah, it's common sense, but it's nice that someone reminds me that I can even use Monolith nowadays. My name is Alex Soto. I work in Red Hat. I'm the curator of lordofthejars.com, and you can follow me on Twitter, which is AlexSotoB, and you can ask me any question in the Twitter, and I will answer as soon as possible. And I'm the author. I know that this is an irony, right? I'm author of Testing Java Microservices. And some of the part of the talk comes from after writing this book. And I said, yeah, maybe Monolith is not bad at all. And but also I noticed that the book is almost ready to be printed, and it was like 2 or 3 years writing it. And basically, I find all the problems that you have in microservices exactly the same, but in writing a book, coordinating all the chapters, the sections, and so on and so far. So yeah, it's more or less the same. If you have any question, please just raise your hand. And well, I cannot see a lot, but then just raise your voice, and raise your hand, and I will try to ask the question. I will try to answer it just when you have it. Why I started preparing these slides comes from this tweet from Kelsey, which said, 2020 monolith application will be back in style after people discover the drawbacks of distributed monolithic applications. And then, well, you see that there is like 1,700 retweets, and then Burr, which is a college mine from Red Hat, says, folks are super excited about this thread. That does feel like we have entered the trough of delusionism on microservices, right? So it seems that now we are getting in this phase where everyone is trying to, move into microservices because we're really hyped, I really love it, so on and so forth. It arrived the peak of inflated expectations, and now it seems that we are in this trough of disillusionment, which is this bottom line, where this part is when everyone has tried to run microservices. It found some problems, and they failed on delivering this technology, in this case, microservices architecture. But of course, this doesn't mean that we cannot learn something from microservices, but apply it in a monolith style. These slides are, I start talking about this like 6 months ago, but 1 week ago, I get this quote from Rebecca Person from a city of TrueWorks, and said, due to the hidden burdens of cost and organizational maturity, microservices will likely never reach the adopt phase. Which is quite interesting, right? Because it means that what's next, in my opinion, the next thing is that some companies will adopt microservices in some way because they really need it. I'm thinking, for example, of Facebook, Netflix. But most of the companies will roll back and go back to, let's call it, a new monolith. And this is what this talk is about. Just as an introduction, probably this is the architecture that you might find for microservices where you have a front end. Yeah, I know that you can split the front end for each of the services, but let's call it, just for simplification, a simple layer that communicates with an API gateway. And then we have several services, one, for example, done with Spring Boot or Wi-Fi Swarm, another one with Python and Go, Vertex or Microprofile, and all of these services communicate in some way, maybe asynchronous, maybe synchronous, using the network, right? This is more or less how it looks, everything, and each of the service at the end is like a bounded context, right, in the DDD pattern. But that's really different if you are talking about Monolith. In Monolith, you have a front end. Maybe this front end is separated, done with Angular or Vue or whatever, or sometimes you are using some template engine like Monolith. And then we have all these services, which at the same time, of course, they talk each other as well. But all of them runs inside the same JVM. It means that there is no network call, just a direct memory call. So how we can get it the advantages of microservices, but inside a monolith application? I've split all the presentation in several concepts. The first one is one of the best things of microservices, which is the isolation between services, right? In microservices, you have a common API to communicate, and then there is a physical layer, which usually is the network, which separate each of the services. And this means that, or it avoids you making some kind of a spaghetti code. I mean that you can still do it, but it's harder, right? Because at the end there is a network call. So you have your service, and if it's correctly isolated, it's going to do a call to another service. So you never mix several concepts between services, because at the end there is a network there. So how can we isolate code in Monolith? So we have an isolation between bounded contexts that happens with microservices. I know that there is several ways of doing this, but in this case, I'm going to show you one which, for me, works really well, which is using the modules that any build tool offers you. For example, this is how I will structure my monolith. This is, you can think about, for example, Maven or Gradle modules. Well, I have, in this case, each of the bounded contexts, one for game, review, and detail, and then inside of the bounded context, I have another module, which is the API, another one, the MPL, and so on and so forth. So I have, this is just a monolith, right? When you clone your project, you get it, this structure. And basically, the API is how it communicates with your public. And public is another module in this case, there's no network involvement. And it's really cool because the API just expresses only what is required. And this favors the low coupling, right? Because any other module can only use what API layer offers you. And then we have the MPL, which the MPL is something that is private, so no one can access to the methods or classes that are inside the MPL module. It's really high cohesively module, because at the end, everything just goes inside this module and reduces your memory footprint, right? I mean that sometimes when you have a big monolith, you need to remember all the classes, how it's called, everything. In this case, you only need to remember the API, which exposes the behavior of the module, but the MPL, it's just, code. So you can just forget it in terms of not maintaining, but yes, in terms of understanding the whole architecture. So, of course, how you get it, all this, that of course you can separate all the teams between modules. And you can use tools like PMD, code assert, check a style, or maybe an enforcer to enforce this architecture so that the API, that any module just uses the API classes and not the MPL classes. Of course, you can do tricky things like using reflection and so on and so far, but for these things, you have code reviews. So every time that you have a pull request, there's be some code reviews to be sure that non-module uses the MPL module. This is one of the things that is really great from point of view of microservices, the isolation of code, but another thing is that the isolation of data, right? So again, when you have several services, you have that each service has its own database, so you have data here, data in the other service, data in the other service. It's really great. So again, we can achieve the same thing, but in Monolith. And again, there is several strategies. The one that works for me most of the time is this one, which is like you have a database, and then for each of the, let's call it service, you have one schema. So what rules are here is that each module has its own schema. The joins only happens inside the schema. So if you cannot do a join between game schema and review schema. Although you can do it because the database allows you to do it. You as a developer must be avoid to do this. And this means that be really aware with JPA lazy collections, because sometimes you do get, and then this get of a field involves a join. So you need to take care of this. But the good thing that you have is like you can use referential integrity across schemas. This means that you can have several schemas, and all of them with constraints. So you are not going to get any violation between data. One of the great things about this approach is that you have global transactions. This is something that you don't have it in microservices. And now, with this approach, you have the real view of the world, because there is no eventually, I mean that all the time the data is constantly done, right? There is no eventually consistently. For databases, you can use tools like Flyway or Liquibase for migrating everything and maintaining the state of all the schemas in a good way and isolated between modules. Let's see more. Probably in microservices, you're using reactive extensions. Basically, this happens because each microservice uses network. And of course, networks are slower than local calls. So it means that we can use reactive extensions for running all these network calls in parallel, right? And I think that one of the most used tools for Java is Reactive Java, which is a library for composing asynchronous programs. And this is an example where you can see that I'm using Reactive Java. And basically, I'm using the zip command, which zip means a combiner. So I want to combine several calls. Which calls I want to combine? The one that comes from calling getGame, getDetails, and getReviews. Notice that these calls are local calls, because we are not in a microservices wall. We are not in this microservices madness. We are just local. So we are doing local calls in parallel. That's fine. Then we need to set, with this subscribe on, where we want to run these methods. You can think about this like a thread pool, right? So if you put that a scheduler is just one thread, then it will execute each of these methods sequentially. And if you have a thread pool, then they will execute it in parallel. Then we need to set how we want to combine the result of these three methods, because each method returns the game, the detail, and the review. And then we set how we can combine all of them. So I'm just creating a new POJO, which is the combination of all three. And then finally, we need to set what to do with this game info object. And in this case, I'm just sending through, in this case, it's a REST API, so I'm sending through to the caller. So even there is no network involved, we can still use Reactive Java for parallelizing our program. Another thing that happens is network. Microservices uses a lot of network. Everything is network calls, but the problem with network is that it fails. So if it fails, it means that we need to make it resilient, in the sense that if there is a failure, we can recover somehow, or we can offer something to the user that maybe a smarter message like retries in 2 seconds because we're going to fix it or something like that. And the truth is that Monolith has a lot of network calls as well, not between the services, but for example, a mail server. If you're sending an email, you have an email server involved. Maybe the database is also a network call, JMS, and so on and so far. So there is still a lot of network inside a Monolith application. And maybe most of you know this circuit breaker pattern. This comes from SOA and a microservices architecture, which basically grabs a function into a circuit breaker. And if some threshold error is reached, the circuit is tripped. So further calls returns error automatically. And this is really important, because it means that when you try to do a network call, there's big operations like allocating a socket, creating all the file descriptor, sending the, trying to communicate all this communication of TCP IP, and after that, you send the payload. So what's happening if you are trying to send something to a service that is broken? All your clients are running all these steps again and again and again and again. Although you already know that the problem is there and they're not going to succeed. So circuit graded, what it does is just open the circuit, so it returns directly an error instead of trying to create the socket and so on and so forth. And after some time, it tries again. So it's like you have like a sleep time, like for example 2 seconds, where all the responses are exactly the same, like a 503 error. And then after 2 seconds, it tries again to connect. And if it succeeds, then it closes the circuit again. So all the calls again works as expected. There are 2 major implementations. Actually, there are 3, but the one is from microprofile implementation, and the other 2 that can be used outside the microprofile is Resilient4j and the well-known Eastrix. Probably all of you know Eastrix, but I suggest you use Resilient4j for one reason, and it's like Resilient4j just uses bavar as a dependency. Meanwhile, Eastrix has a lot of transitive dependencies. So I think that it's something really nice to have in a monolith application and take care of your transitive dependencies. And this is how Resilient4j works. You need to define a circuit breaker, which defines, you put it a name. In this case, I'm getting all the database calls inside this circuit breaker. And then this is the wrapped function, which is like a JPA call, which I do simply entity manager will find this game. And this is the method where there is some network implications. And then I said here that if it fails, I want to just return an empty object, an empty game, an empty detail in this case. Of course, you could put here something like go to a cache system and get it some stale data or whatever. But this is really the purpose of circuit breaker. If everything works, it just returns the real object. If not, you can program what to return. And let me show you here this the example. Wait. This is the example that I've been talking now about games, details, and reviews. This looks quite small, but you, okay, now we have here the details, the reviews, and the game page. I have here my pom.xml. For example, in the details, I have the API, which I just exposed here an interface. You can see here the detail service, which is just an interface, which returns find detail by game ID. And for example, if you check here the MPL, I have here the target, some tests and so on, and here in the Java, I have the detail service, which is the implementation of this service. This is some class that if you check, it's packaged. It's packaged for testing purposes. It's not private, but this means that any module from outside this detail service cannot reach this MPL. I mean that any class in the MPL should be in this code with package. And then I also have these flyway resources, where it basically takes care of creating the database schema, which you can see that here I'm creating the schema of details, and then I'm just creating the table detail. And now if we can run it so you can see it, but I will need a bit of help, because here I have, this game page is like the web page plus the application which combines all the services. And if I'm going here in resources, DB, I have this file, which is a database, and I'm just adding here reviews. The first game that I have here is The Secret of Monkey Island, and I put it here a rating of 4. Are you okay with 4, maybe 5? I mean, it is one from 0 to 5. 4, 5? 5? Okay. Put it at 5. The next one is Monkey Island 2, which I like it more than The Secret of Monkey Island, so I put it at 5. Are you agree with 5? You didn't like it? Yeah, 5? Great. Next one is Indiana Jones and the Fate of Atlantis. I put it at 4. 3? 3? Okay. I'm going to put the 3. Doom. That's another style. I put it at 3. I didn't like it so much, Doom. I like it more, Doom 2. But Doom, let it 3. Yeah? Okay. And I think that there is another one, the final one. No, there's more. Day of the Tentacle, true. I put it at 5, I guess. Yes, a 5. 5 is okay? Yeah. And the final one is Thimbleweed Park, which I've not played, so I put it at 0. I don't know if anyone has played this. This is the new game from Ron Gilbert. Nobody? Yeah? Which, 5? Yeah? Okay. There is only one vote, so we're going to put it 5. So now I can just minimize this. I'm going here. I'm even package. And meanwhile, I'm going to show you another thing. Wait. Which is this important test, which is in here, which is called dependency test. And that's really important test. Because what I'm doing here is analyzing code and assert that nobody from modules can talk with other modules. And it seems really a strange test, but you see that it's really easy. You see that I create a test called dependency, and I have a class, it's called Lord of the Jars Games. What you need to think about this is like, this is a package which is org.lordofthejars.games, right? This is how I identify a package. And then I have here a dependency rule, which is called game API, game MPL, details API, or reviews API. What you need to think about this is like, it's a package. So these fields inside this class is org.lordofthejars.games.game.gameAPI, and so far. So if you check the code, you will see that these packages. And then I'm going to here start defining some rules. And I'm saying the game, it means that games.game can only use .gameAPI, game.api, details.api, and reviews.api. What I'm saying here is that the game package, which is the root package, can only use the API. If the game is using any class of the MPL package, then this test will fail. And then here in the game MPL, I say that it can use game and game API, because I mean that it's the way of you say that the game MPL can use himself, right? Then if I run this test, it will be green. But if I change anything in my code, and then my code start to do some import to, for example, the game imports game MPL, then this test will fail. So it's a way to maintain the code isolated. I think that, no, what's, wait. Okay. It's going to work faster. And now I just move from here, target games. deployment. So now I'm just going to start Wi-Fi and deploy the application, which goes pretty fast. And then here you can see the Monkey Island, you put it at 5, so you get it at 5. Let's see, I think that it was 3 was due. Indiana Jones and Fatal Latin, you put it at 3. So there is a 3, and so far. So yeah, really easy application, which works pretty well, everything done in the monolith style. I'm going to stop this, and now I'm going to continue with something that is really cool, which is like embrace DevOps. I mean that if you are in a monolith application, doesn't mean that you don't need to use DevOps at all. Because one of the important things about microservices is to reduce the time between committing a change to a system and that change being placed into a normal production while ensuring high quality, right? So instead of month, you just can deploy several times, maybe every day. And this seems that it's something that you can only achieve using microservices, but with Monolith, you can do it as well. And the first thing that you need to, let's say, start using is Docker, right? I mean, that Docker is just awesome because it allows you to define all your stack. So you have your Docker file, you set all your prerequisites there, like which Linux kernel I want to use, the Java version, the application server, all my custom configurations, so on so far. So then you can just define this, create the Docker file, and create the container, and all your container contains all this configuration stuff. And still you can use Monolith with Docker. There is no problem in that. And one of the big advantages that you're going to have with this is that now I remember some time ago that in my company we have a Monolith, and to deploy this Word file, we use mail, right? So we just send it a mail to the ops guy saying, look, this is the URL of Nexus where this is the word that you need to deploy. We need this JVM. We need all this database and so on and so forth. So please deploy it. So we did it by mail. Which is maybe nowadays you are still doing something like that. But we did it in that way. It was not really a cool way of doing it. And then I moved to another company. And then I arrived to the company and I asked it, hey, how are you deploying? And they said, because in my previous company we used email, and they said, oh, we are really smart. We are using a wiki page. And we're like, okay, it's a wiki page that it's never updated. It just works the first time, but the next time never works. So if you want to avoid all these kind of things, just use Docker. You as a developer will define your expectations. You're only going to provide the Docker file, and then someone will build the container with your Docker file. So this is sometimes how my monolith applications looks like. It was like a load balancer. We have the same monolith server replicated, right? And then we have 3 databases. I mean that for just mirroring, and all of them sync, right? This is sometimes how you get it with monoliths. It's pretty simple if you compare with microservices, which you need a lot of services running. And how you can deal this with Docker, you can start doing Docker run of the service A, Docker run of the service B, Docker run for each of the databases. And if you get it some problems, you can just say, hey, look, this container is behaving abnormally. I'm going to do a Docker stop and Docker run again manually. This is one way of doing, but this doesn't scale so much. So of course, you need to start deploying to Kubernetes. And nothing blocks you of using Kubernetes again with a monolith. It's okay. You just will see how easy is deploy a monolith, because when I started comparing how I deploy a monolith in Kubernetes and how I deploy a microservices with Kubernetes. I mean that with Kubernetes simplifies a lot, but there is still somehow complicated. But when you try to do it the same with Monolith, it's really, really easy. You just set, in my case, I set here replicas equal to, and that's all. And this will make me my application service replicated twice. And here I put it the container image, and this is the port. And I can do exactly the same for my database. So this was the example of what I've showed before, the schema, where I have 2 instances of game service, 3 instances of CockroachDB, which is the database, which works pretty well for the cloud. And then I have here the reverse proxy router, which is like how you get into the Kubernetes. And finally, here you can see the number of instances, which are 2, and this service just acts as a load balancer, so you don't need to take care of any load balancer. So most of the infrastructure problems that you might have with a monolith are all of them solved by just using Kubernetes. I'm going to show you a quick demo of this. In this case, I'm going to show you, let me run it first, and now I explain it. OK. Basically, what I've done now is just OK, it's running. What I've done here is just go to, I don't know if you know what is OpenShift. OpenShift is Kubernetes for enterprises. It's like Kubernetes plus some of features, and this is one which is called source to image, which I set when I do this OC new APP. What I'm saying is like, please cluster, go to this URL, which is Lord of the Jars Games Monolith. Use the, wait, sorry. Oh, I moved. And what I'm saying here is saying that, please, I want to use the Wildfly Docker image to build my package. So basically, what OpenShift is just cloning this repo locally, build the project inside the cluster, then take inside the Wildfly image, and then take the word and put it inside a Wildfly image. So now everything is deployed automatically. And if I do, for example, shift start, sorry, it's already started. No. I don't know where is here. I have here my project, which is the game, which has been deployed. You can see here that there's one pod. And actually, well. And then I can just create a rule, and I can access here. Notice that this is the Wildfly that is running, and if I go in a games/2, for example, I get the Monkey Island to deploy it in OpenShift with just running one call. Really easy. For microservices, more complicated, but with Monolith, it's really easy. Wait, this demo. Also, probably if you are into microservices, well, you're listening about this, that all your services must be cloud native application, which basically means that you need to be able to scale up and down at a rapid rate automatically and recover in case of errors automatically. When I was developing in Monolith, sometimes I have, again, this thing, and I have something that is called a sticky session. Well, basically, a sticky session is like a database, let's call it, where you said, it's the first time that this client has made me a request, so I'm going to load balance between service A and service B. I'm going to go to the service B, and then I'm going to store a shopping cart, for example, in case of a shopping cart, I'm going to create an HTTP session, right, which is the shopping cart. And this HTTP session is created inside the service B. So my service B contains all the information from the shopping cart. What's happening if the service B goes down? That I've lost my shopping cart, obviously. And then if the client tries again to reach this, does another call, it will say something like, oh, my shopping cart is empty because the server is down and all the information about this shopping cart was in that server. So how this is fixed in microservices is like creating an in-memory data grid. An in-memory data grid is a data structure that resides entirely in RAM and is distributed among multiple servers. So it is something like this, where all the services runs with in-memory data grid. And this is where, when you store some element in your shopping cart, instead of, it doesn't matter in which server takes your request, because the in-memory data grid is going to replicate across all the in-memory cluster. So now what's happening if the service B goes down and the in-memory data grid that was in that service is also down? It doesn't matter, because then the load balancer will go to the other service and it will just get it the shopping cart that is being replicated in the grid. This is something that you need to change in your monolith, right? Because you're adding a new layer, which is this in-memory data grid, which there are several ones, but I recommend you, if you are using Kubernetes, start using InfiniSpan because it integrates smoothly. You can even release as unicorns, right? You can release several times per day. And to release as unicorns, you just need to, create your Docker file, build a container, deploy this container to your cluster, then testing in production, which means that you need to test that everything works as expected. There are several strategies, for example, blue-green deployments, canary deployments, or dark launches. In my experience, the best one is dark launches and then canary releases. And then finally, when everything works as expected, you can release your new monolith. There are several tools that can help you, for example, S2I and OpenShift that we have seen here in the demo. Also, there is Fabricate, or Fabricate Maven plugin to deploy, and also there is Istio if you are into the blue-green, AB, canary, and dark launches. And of course, if you want to test in production and you will face several problems, some of your solutions are Tate and Debezium. So let's wind down. Some of the advantages of the monolith is that everything are local calls. It's incredibly simple. All parts are always up. So you can take your monolith, scale up for like having 5, 6, 7 instances of the same monolith application, and everything will run. If one application server goes down, doesn't matter. There is 6 or 4 or 2 or still 1. But in microservices, maybe you have hundreds of services deployed, and maybe ones of the services start going down. So now, not all the system is always up and running. It's easy to debug. I know that you can use, for example, telepresence or kubesquash for debugging inside the cluster, but I think that it's really easy to debug a monolith and quite hard to debug a microservice. Easy to test because at the end, everything is there. If you have several microservices, then you need to start booting up the other services to test or using service virtualization to test. This is something really cool. If you are inside, if you have done some microservice architectures, I'm sure that you faced this problem. And it's that with Monolith, you can refactor without running surprises, right? Because you refactor, you change a name of a method, and if you have done correctly with the IDE, everything will be changed automatically. If not, you will get some compilation errors. But if you are in microservices and you change some return value, then you said everything is fine, everything is working as expected. I'm going to deploy it to production. Oh, everything starts failing because the consumer is not expecting what the producer is doing. And this is something that Monolith, you don't have these problems. You see all the time the real world because the transactions are global. And I think that it's really easy to deploy. You only need to do, I don't know, in this case, I do OC, new app, blah, blah, blah. In any cases, you can just do Maven clean package and then Helm, whatever. But it's really easy. In case of microservices, you need some kind of coordination. And of course, if you say, yeah, but I like so much the microservices approach because I can use several languages. Okay, you can still use it several languages. Of course, you need to all of them based on JVM, but you can create some module with Ruby, another with Kotlin, another with Java, another with Scala. So it's still possible, and even you can use several databases. Nobody stops you of using a MongoDB and PostgreSQL without any problem in the same monolith. Also, it's really easy to migrate. If you follow all these advices that I've done here, it's really easy to migrate to microservices. But I really like this slide from Bohr, which is like digital Darwinism. So if you are not able to deploy several times your monolith to production, what makes you think that you are going to be able to deploy several times a microservice architecture? I'm sure that you're not going to be able to do it. Trust me. Because if you cannot do a simple monolith, you're not going to be able to do it with a really complex microservice architecture. So you need to adopt all these stages before you want to move to microservices. If not, no worries. You're going to do this in the near future. Yeah, I'm going to move to Docker, Kubernetes, and so on and so far. OK, you're going to just born. And who knows what is Stack Overflow? Everyone. Everyone has done copy-paste, right? This is Stack Overflow. And I see here that you can see that there is an stats service, right? This is the stat of each question. There is a question service, right, for the questions. Then there is a user service, where is all my information. Then also the question service is also ask a question button. And then we have this advertise service, which is to getting advertisers, right? This is a really cool microservices architecture. The problem is that this is a monolith. Stack Overflow is a monolith, just a monolith. There are like 10 servers, some load balancers, and 3 DBs, and that's all. And then think about when you said, I need microservices because I'm going to have a high level traffic. Yeah, then think about the Stack Overflow, the traffic of a Stack Overflow, and they are running as a monolith. And the funny thing is that if you check here this number, just go to the bottom page of Stack Overflow, you will see a number which is like the date and then a number. Just remember this number, refresh this page after 15 minutes, and you will see that this number has changed. This is not the number of visitors. This is the version. So they are deploying a monolith application every 10 minutes. It's a monolith. They are really cool, and they are working pretty well. So long life and prosperous to Monolith. And if you have any question, you can send me an email or Twitter. And you can also, if you want to have download several books about monolith, data, microservices, and so on and so forth, just join Red Hat Developers. Thank you. Yeah, if there is any question, or I mean that you can approach me in the venue, I have no problem.
Hello. Does it work? Yeah. Hi. Thank you, Alex, for your talk. I very like it. This question is not about criticizing because you are a top star, and I very agree with the things that you just mentioned and walked through. But just I would like to ask you about what is your view about scaling, for instance, the database? Because you were mentioning like, yeah, what about I've got a state on my server, and so then I need to take that state out of the server. But in terms of the data on the database, what would the approach that you will follow to scale horizontally data?
Scale the database? Or
yes, the database.
Yeah. Well, to scale, I think that nowadays there is a lot of problems scaling the traditional SQL databases. I mean that I have no production experience with that, but I play it a lot with CockroachDB, and it works really well. Because it has been developed from scratch to be cloud-enabled. So I suggest you use this, because you can scale up the database to 3, 4, 5, 6, 7. It doesn't matter the number. And then you just do an insert. And even it uses the PostgreSQL driver. So it means that any application that works with PostgreSQL, they say that you can just move up to a CockroachDB without changing the driver. I tried with JPA and it worked pretty well. And they take care of replicating data when it when node is down, it tries to recover automatically and so on and so far. So I mean that in case of SQL, I will suggest, but it's not this is not also about Monolith, just also for microservices. I mean that CockroachDB, I think that for nowadays, if you are thinking about something not tied to, for example, Google or Amazon, then I would say that this is the best approach. All right, thank you very much.